So in this section, we'll start by talking about molarity, and then we'll talk about measuring percent solutions, and we'll talk about measuring parts solutions, parts per million or parts per billion. So the first one we're going to look at is molarity. So again, we've already have definitions for our solute and our solvent. We know that a solute is a substance that's dissolved in a liquid usually. Our solvent is the liquid in which a substance is dissolved. It doesn't have to be a solid in a liquid, but we know that the solvent is the one that's in greater concentration. The solute is typically in a smaller concentration. And when we're making solutions in the lab, it typically is a solid being dissolved in a liquid, or we can have a liquid being dissolved in a liquid. These are the most common types of things that we will make in the laboratory. So our solution is going to be our combination of our solute and the solvent. So a very useful means for expressing concentration in the laboratory is molarity. And so molarity is defined as big M. And so this is going to be the number of moles of solute that's dissolved per liter of solution. So that's the definition of a molar solution. Molarity, big M, equals the moles of solute on the top over the liters of solution on the bottom. So this is important. Liters of solution, not liters of solvent. So our solvent is the liquid, but when we place the solute into that solvent, we make the solution. And so if we are taking a bath, for example, right, you'll fill up the bathtub. You don't fill it all the way full because what'll happen? You'll get in and the water will overflow out of the bathtub, right? Because you're displacing volume with your mass. The same thing happens in a solution. If you put a solid substance into this solvent, the volume of the solution changes, right? It's both of these things are going to make up the solution. So the liters of solution is the combined amount of the solute and the solvent that make up the solution. So this is the total volume that you have after you mix the solute in the solvent. The moles of solute are just dependent on the solute concentration. They don't depend on the solvent concentration. So we've already done a review at the beginning on Tuesday about what a mole is. So remember, our mole is equivalent to the formula weight in grams of a substance, and it's also equivalent to the amount, or 6.02 times 10 to the 23 molecules of that substance. That's our definition of a mole. So a 1 molar solution is going to be a solution in which 1 mole of compound is dissolved in 1 liter of total volume. So that, again, is the solute plus the solvent. Has to equal 1 liter. That's our definition, our predefined definition for a 1 molar solution. So 1 big M equals 1 mole over 1 liter of solution. So if we take an example, what is a 1 molar solution of sodium chloride? So if you had the molecular weight of sodium chloride, we know that that's 58.44 grams per mole, right? Because our sodium is going to be, so we take a look at our periodic table, again, our little Bible, we can see that the sodium is about 23 grams per mole. And our chlorine is about 35.45 grams per mole. So if we add those two together, since there's 1 atom of each, that would add up to 58.44 grams per mole for sodium chloride. So if you dissolved 58.44 grams of sodium chloride in a final volume of 1 liter, so usually if I did this in the lab, I would take about 800 mils of water. I would go ahead and add my sodium chloride, and I would stir it all up until all the sodium chloride is dissolved. And then I would put it into a graduated cylinder, and I would bring up the volume to be exactly 1 liter. This solution that you've now made is a 1 molar solution of sodium chloride. So we'll practice doing some molar problems. So here's our first question. If we have a 4-gram sugar cube of sucrose, which we know the molecular formula for, it's C12H22O11, If this is dissolved in a final volume of 350 mils with hot water, what is the molarity of the sugar solution? So we know that our big M is going to equal little m, or moles of solute, over the volume, which is the volume of the solvent plus the solute, so it's the complete volume, in liters. This is going to give us the molarity of the solution. Okay, so in our problem, we know we start out with 4-gram sugar cube, and we have 350 mils total volume, and we know that the molarity is the number of moles of solute over the number of liters of solution. So the first thing that we see is that our volume is not in the correct units. We have our volume right now in milliliters, but the volume for molarity has to be in liters. So we need to do this conversion. We need to get liters as our total volume. So do you remember how many milliliters are in 1 liter? So we know we've got 350 mils, and we're going to need to multiply this. We want our answer in liters, so liters has to go on top. So we know that 1 liter contains how many mils? Hopefully you said 1,000, right? 1,000 milliliters are in 1 liter. So review your metric system. I'll put up a metric system guide again in Moodle so that you can print that out, keep it in your notebook, refer to it often. We can come here, we can cancel out our milliliters. We're going to be left with our answer in liters. Essentially, you've got 3 zeros, so we can move it back 3 places with the decimal. So this is going to be equivalent to 0.350 liters. So now we have liters for our volume, for our solution, and now we need to convert our grams into moles. So we do that by finding the formula weight of our sugar molecule. So our sugar molecule is C12H22O11. So we need to first calculate the formula weight. So let's leave that there. So we need formula weight for this molecule is going to be all of these atoms added up together. So we've got 12 carbons times the weight of the carbon atom. So remember your periodic table. You can go ahead and grab your periodic table. So our carbon is 12.011. Plus 22 hydrogens. So 22 times our hydrogen is 1.0079, say 1.008, plus our oxygen, there's 11 oxygens, and the molecular weight of our oxygen is 15.999. And that is going to equal the formula weight for our compound. So this component is 144.132 plus 22.176 plus, or 342.297 grams per mole. Right, so that's our molecular weight, or our formula weight for sucrose molecule. So we can round this up because our total volume is going to be 3 significant figures in this case. So we can just round this to 342 grams per mole, and we can use that in our equation. So we need to convert our amount of sugar in our sugar cube, which again was 4 grams, into the moles that we have of the sugar. So we're starting out with 4 grams. And we want to convert that to moles. So we have to have moles on top, grams on bottom. So we know that 1 mole contains 342 grams. And this will enable us to cancel out our grams and leave us with our moles of sugar. So this is 0.012 moles of sugar. So now we have our moles of our solute. So we know again that big M equals moles of solute over liters of total solution. So we can go ahead and put both of these values in, right? Because we've got our volume up here, when we've got our moles right here. So we can put these values in and calculate the molarity of the solution. So this is going to be 0.012 moles divided by our 0.350 liters, and that's going to equal 0.033 molar. So our solution is going to be 0.033 molar. That's the molarity of that solution, the moles per liter.